The goal of this section is to use a tangent line to come up with an approximation for a more complicated function. So we're going to go back to what we did previously, which is just finding the equation of a tangent line. So in the first example, you're given a function cosine of x. I want you to find the equation of a tangent line at x equals 0. And then we're going to use a calculator to compare certain values. So anytime I ask you to find the equation of a line, you should be thinking I need a point. This is my x value, so f of 0 is going to be 1 because cosine of 0 is 1. So there's my point. I also need the slope. The derivative is going to be negative sine of x, and the slope at x equals 0 is going to be 0. So here's my point, here's my slope. If you write the equation of a line, it looks like this, which is really the same as y equals 1. So what this is saying is, if you think about the cosine graph, in this interval here it looks like that. Y equals 1 is your tangent line, which makes sense, right? It's a horizontal tangent, and at that point they share the same point. Now what we're going to do is compare the value of the line and the value of the function at some other points. So let's say this x value right here is 0.05. So obviously the line and the cosine graph have different y values. If you punch in cosine of 0.05 on your calculator, you're going to get approximately 0.99875. The y value of the line would exactly just be 1, so the approximation from the line is just y equals 1. The idea is that these are approximation. This is an approximation to the actual y value. So as long as you are very close to this point of tangency, the y value of the line is going to be a decent approximation to the y value of the function. And later on we'll talk more about what decent means, what the error is, things like that. So all we're going to be doing is finding the equation of a line and comparing it to the actual value. Okay, so I want a tangent line approximation, so that just means we need to come up with the equation of a line. Here's my point. I need the slope, which is going to be the derivative, which is cosine of x. At x equals 0, my slope is 1. So y minus 1 equals 1 quantity x minus 0. So you can leave it in this form. And then if I ask you to approximate what happens at 0.05, 0.1, you would just plug in the x value and give me those matching y values. Okay, now let's go ahead and try this one. So without a calculator, I want you to approximate 0.998 cubed using a tangent line. So in this problem, I don't actually give you the function. You're going to have to come up with the function yourself. The function is really, you're taking a number and you're cubing it. So f of x is x cubed, and you need to come up with a point to use. Now we're doing this without a calculator, so we want to use a point that we can cube pretty easily, but that's very close to 0.998. So that number that we're going to use is x equals 1. So again, once you have this, we're going to do the same thing we did before. We need a point. My point is 1, 1. I need a slope. My slope is 3x squared. At x equals 1, my slope is 3. There's my slope. There's my point. Write the equation of the line. Get to this. So using the equation of the line, the approximation for 0.998 is going to be, I'm going to plug in 0.988 for x, move that 1 over. If you punch this out, this is 0.994. So this is the approximation using the equation of the tangent line. Now if you go ahead and typed in 0.998 cubed on the calculator, it actually is 0.994, and then it goes on. So it's a pretty close approximation. Okay. Here's another word that you'll see that means the same thing. Find the linearization. Again, it just means find the tangent line approximation. Here's my function. Here's my x value. So we need a point. So if I plug in -4 here, my y value is 5, square root of 25. I need a slope, which is going to be my derivative. Bring down the 1/2. Reduce the power by 1. Don't forget chain rule. And if you simplify this, this is what you get. And if I plug in x equals -4, your slope is -4/5. So here's my slope, here's my point. The equation of the line is, leave it in point slope. There it is. Okay, last one, same thing. Find the linear approximation. So when you see those words, you're just thinking, I need an equation of a tangent line. But again, here, I don't give you the actual function. I've already plugged in a number. So you can just start with the function. You're just taking the square root of a number. We need to find, we're going to do this without a calculator, so I need a number very close to 15.9 that I can take the square root of easily. I'm going to use 16. Once you have this, then just come up with the same information that we did before. My point is going to be 16 comma 4. There's my point. I need a slope. This is my slope. If I plug in 16, my slope is going to be 1/8. So this is my equation of the line. Y minus 4 equals 1/8 x minus 16. So that's my equation of the tangent line. Now I do want you to actually tell me what happens at 15.9. So you're going to plug in 15.9 here and punch this out over, this is 1/8, this is negative 0.1 plus 4, and this is actually 3.9875, which is actually very close to the square root of 15.9.